You are given two integers n and s. Return the largest integer that has at most n digits and whose sum of digits is s. If no such integer exists, return -1. We have at most n digits and the sum of the digits is s. We have to return the largest integer that has at most two digits and sum of digits is 9. That is 90. Okay, two-digit integers. At most two-digit integers, sum of digits is 19. There is no integer with at most two digits that has sum of digits of 19. Because two digits can never sum up to 19. Maximum they can go is 18, right? If you take both 9. Okay, for n equal to 5 and x equal to 0. Can I have the only non-negative integer whose digits sum to 0 is 0? Uh, Largest integer we have to print. In this case, you can also print 7 and 2. At most n digits, right? Two digits, and we can also print a single line in. Okay. Well, it is still told at most two digits. Largest integer that has at least 90 terms, right? 72 is less than. You have to maximize the tens place in this and took this one. Actually, we have to maximize which one in this. That hundreds place. Example, if we have n equal to 3 and s equal to 9. We have three places at most. We have to get a sum of 9. You can place 9 here and make the zeros. If we have n equal to 4 and sum is 18, you can place the two lines here and place zeros. 9900 would be the answer for n equal to 4 and s equal to 18. If s was 70 in this case, we could have done 9 and 8. The value that s can be achieved by the sum of 9 and 8. Get the like maximum numbers for some chemistry, right? Numbers can be from 0 to 9 because they are digits. 9 and 8 9. Sum is greater than 80 and n is anything 2, 3, 4, 5, and so on. N is 2, then it's not possible. N is 3 and sum is 20. Is it possible? N is 20 and N is 3. 9, 980, 220. We have to deal in terms of 9 maximums. Like, right, so we have to incorporate 9 at the hundreds place or the first max significant MSB. Then we have to decrement, right? If n is equal to 2 and s is equal to 19, I will place 2, I will place 9, I will place again 9, then it's over. And the sum is still remaining. So answer is 9. We can just, but if n can be up to 5, that's a good, very low constant question. You can just know if we can find a string, then we can convert that string to integers. So we can write a string temp or string max number is equal to empty. Okay, state for n 5 equal to 0, I less than n I plus plus. We can write if uh, we have to find the largest digit, which is 9. Sum is less than 9, with 9 with 8. Like two cases, if S is less than 9, then you can go with max number dot max number is equal to max number dot push back. Instead of formula, then you put form a vector as well, right? Vector can convert to a number. Or it's the value of the brain. Max number 2, max number dot push back uh, the number which is S. S is 8 suppose. You know, but well, S is definitely less than 9. So you will definitely push S. Like S can be 1 also. You will push 1. Then it will decrement S with S. If S is a single digit number, 7, then N can be as large as possible or as small as possible. N can be from 1 to 5. Right? So even if we have 5, then we can put S for the 7 and just zeros. It will be the maximum values in zeros. Right. So that's the case. And S has to be positive here, right? S will become 0 here. We have to handle this case separately. We will make it low come here. If S is less than 9, what is the range of S? This can be right. So if S is less than 9, we can do uh, can return S into that is what is 5. So we put 5 at the first place. So the maximum significant bit. It means this is 5 and this 1. 5 into the power 3. Power of n and minus 1. That is the integers. Yes. Otherwise, we will go to the string max number and then find the answer. Uh, 6, 9. S will be right. So it's equal to 9 and S minus equal to 9. We continue for 10 times. And write y there. While I testing and then add maximum, you can append, keep on appending 9 and then while I is less than 10 and S is greater than 9. S is greater than or equal to 900. Then you can keep on appending it. Like for example, S is 17 and N is suppose 5. 2, 3, 4, 5, 4. You have to declare I also int I equal to 0 and it's 5. 1, 2, 3, 4. Then append a 9 here. S is 17, right? Will be 9 here. S will be divided by 9. 17 minus 9 is 8. Then you have to place all zeros. If I has passed, then is fine. Otherwise, S is distant nine. You can depend most pensions. How many will you can remaining things? So, so probably is one. I and total and marks numbers still good to because it I do I happen to use better than yes 900 and it's zero. J is equal to I plus 1 which is it and I is um, um, 9 and 9 I is equal to 10 S is equal to 10. Won't depend zeros. It will depend on 1. Then you find 0 S is 5 will be depend on 5 and still if uh, I is a banana then go for this. Maybe I would it if I have on one. create two time series. Mm, we are given two integer arrays, series 1 and series 2. 2D array. Each element in both series is of the form timestamp or value, where timestamp is an integer representing the time and value is an integer representing the value at that timestamp. Each array is sorted in strictly increasing order of timestamp. This array is also sorted in increasing order of timestamp. This array is also sorted in increasing order of time. Okay, for any timestamp not present in a series, its value is taken from the next available timestamp in the same series if one exists. Otherwise, its value is considered zero. The aggregated series is formed by summing the corresponding value from both series at every timestamp that occurs in another series. If you turn the aggregated series as the two-integer array of timestamp of some value where it's ordered in simply increasing order of timestamp. Okay, so let's see example. Series 1 is 1341. This is timestamp and it is sorted in the timestamp. Sorted in strictly increasing order of timestamp. Series 2 is also sorted in strictly increasing order, not non-decreasing. It's strictly increasing. Okay, then we have to aggregate them or we will combine them. The combining rule is either for any timestamp not present in a series, its value for any timestamp. For example, here 1 is present, but here 1 is not present. So 1 is present here, but 1 is not present in series 2. So we have to apply this rule. For any timestamp not present in a series, its value is taken from the next available timestamp in the same series if one exists. So here the value of timestamp 1 is not available. Then we have to take its value from the next available timestamp in the same series, which is this one. So value is 2. So we will take 1 comma 2 and 1 comma 3 here. We have to add them. 1 comma 3, 1 comma 2 value will be added. There will be 1 comma 5. Let's say here is 2 comma 5. Okay, next available timestamp. So this is used. Okay, consider it to be used. Next we come. Next we come. Uh, 2. 2 is the next, not 4. 2 is the next smallest one. We have to maintain the aggregated series also has strictly increasing order. We have to maintain the aggregated series also in a strictly increasing order of timestamp. So that's why we are taking this 2 after this 1 comma 5. So this has been processed. We have to, we are here, comma 2. Right. So 2 is not present here. They have to take from the next available one. Right. Next available one is this because it has been already been processed. The 2 comma 1 will be there. In this case, 2 comma 1, 2 comma 2 will be 2 comma 3. Then this is consumed. This is consumed. This is now remaining. 4 comma 1. 4 is not here. Next available timestamp. Next available timestamp. Greater available timestamp. Suppose 5 comma 2. 4 comma 1 plus 4 comma 2 is 4 comma 3. 5 comma 2 is present here. 5 comma 2 is not here. Then it is not available. Then we have to take it 0. Yeah. Then it is 5 comma 2. So we have to do this kind of stuff. Yes, how can we solve this? If we have a series 1, which is 1 comma 3, 4 comma 1, then we have 2 comma 2, comma 5 comma 2. Series 1, this is series 2. This is main thing is that if any timestamp is not there, not present in any series, we have to search in that series itself for the next available timestamp. If one exists, otherwise result will be 0. So we can use lower bound here, right? Some kind of lower function. Suppose we iterate on a series, then we find that uh, corresponding with corresponding time step is not available in the other series. So the other series should know the next time step, the lower bound of that. Okay, we understand this, right? You can think like we have to maintain two pointers. Like we did the standard problem on uh, merging two sorted arrays. So that's the narration of that. You can think of like that. 1 comma 3. So 1 comma 3 is the here pointer I, here pointer j. So I wala value is smaller than j wala value. Okay, so I is smaller, right? J is bigger. So we have to search if 1 3 is then here. No, because if it would be there, then it would be it would have been already at j, right? So we can just take the lower bound of this one. Or we can just start with j. 1 3 1 2 3 1 5. I moves there, j moves there, to Rentgen moves. Then this and this. This is lower. The 2 comma 2 is not present here. I is here. We have to take 1. 2 comma 3 comes here. J moves here. I was still here. And I did his job. I did his job. J was here now. We can have 2 comma 3. We don't even need to lower down. We can just iterate on like them merging two sorted levels. Our file, we can iterate linear diagonal vertical view, acceptable where it's just right. So this sign is equal. No, size sign may not equal, right? This obviously int n is equal to ct 1 dot size, int n equal to 350 dot size, can write int 5.0 or j point to 0. Then we can write while 5 is less than n and j is less than n. What can we write? This this is take the word like this one and if already they are sorted in strictly kinematics, both T1 and 60. If series 1 of I, that's vector of we have to take I of 0 is 1 is uh, if both are equal, right? Both will be null. Okay, this is 18 because then this series 2 of j, current j, series 2 of j of 0, series 2 of j of 0. Then we can write, uh, we can just move, maintain the vector total into answers. Can write answer dot push underscore back. Smaller one is series one of while you can push this entire two length vectors and then element of series will zero to answer and I is plus. Else if series one of I 0 is greater than strictly greater than series 2 of j of 0. Then again we can do the similar thing. Answer dot push underscore back series 2 of j. You can write also say into the brackets And we can do this. Okay. And now else, if both are equal, then we have to push both and implement both. After this, and this to work J. If someone finishes earlier, but the logic is that if one is there, right, we have to push this. We don't have to push this. We have to push the sum of values. So that's an issue here. We have to push uh, mm, this the vector of in, the vector of int to pushed. Then the create a vector of int to push is equal series one of I dot first will be lower, right? But that one will be remain because that's the timestamp and j is starting from 2 itself. So we have to take j itself, right? Comma series and the value should be series uh, 1 of I dot second or dot second name. Not it's not pair, it's only vectors. Here I of 0, here is I of 1 plus series of j of 1 if j exists. I have to make sure that oh, let me make this. Yeah, first element this is this entire thing. But if you hit a condition, if j is less than n, then only we can uh, okay, you can write more cleanly like this. If j is less than n, j less than n, then second plus equal to should leads to j to 1. Otherwise, the condition could be 0 as demanded by the question. Then you can put constant pushback as a vector, right? So we can write vectors of int to push first and second. Then we can write to push. Similar to this, we can begin the else if case. First would be series 2 of j of 0 because that's smaller value. And second would be series 2 of j of 1. If I is within the bounds, then we can increment second gets series of 1, I of 1. Right? If first second of this issue. They both are equal. Then it is very good. In just the answer our suppose one is 1 comma 4 and other is 1 comma 2, then the answer will be 1 comma 6. So we have to add in value. Right? We can push that can we push back. You can write kilometers in push back itself. I'm actually like two push is equal to um is both are same, right? Series one of zero or series two of zero then as was right. Series one. That's right. Okay, and one more thing, human behavior, human are which both I get I comma zero and series one of I of one plus series two of j of one. J of one, right? Series one of I of one plus series two of j of one. Series one into series two of j of one. Yes. Two underscore equals one says yes, I just going to this one says if it is not in the bound, then it is automatically inspected. We don't have to find another parameter. Now let's check what comes waste is 15234 3. Okay, so we have to um, file file less than 10. Suppose J has been finished. So you just have to, since J has been finished, so we won't find any uh, one there. We have to anyways take a zero for that. Right, so I is less than 10. So this should be modified to something. First, second, you can keep it like that. It is also, it is already been out of bound. J, so we have to move this. Second is just series one of, I have to just push back everything. You don't even need to write this. You can just write answer dot push back series one of, again while j less than n, answer dot push back. Well, I has already been auto bound, so we won't find that matching timestamp there and zero. Yeah, uh, series two of j added. Now let's take 1 5 2 3 4 3 1 7 2 3 3 1 10 power something like that. Okay, submit, accepted, count direct sequences, count direct sequences. You're given two possibilities, n and k, and k possibilities. Valid sequence of k possibilities such that when a sequence is valid, it is a sequence of k positive integers. So you have to start with one. You write this. You write in the editor valid sequence is of k positive integers. We have to start from 1, which is greater than equal to 1. Right? Hmm. Okay. So writing here in right in here file open folder automations in this um, innovations. Problem third, uh, problem third, innovations. Leetcode, weekly, segmented word, CKP. But the beginning of this last what is the valid sequence? Valid sequences of K positive integers. So in getting this I will one and more trace. We start with one or more. Sum of all integers in the sequence is equal to n. Okay, n and k are positive, n and k are positive. N comma k is greater than 0. Positive integers. So we have to write this. What is the correct sequence? Sum of all integers in the sequence is equal to n. Sum of all k integers, k of all elements is equal to n. Product of all integers in the sequence is even. That's a good point. Product of all elements is even. Product of all elements is even. Return the number of inner sequences. Since the answer may be very large, return it moderate at 10 power 9 plus 7. Two sequences are considered different if they differ at any index. For example, 112 and 121 are considered different sequences. Uh, okay, number of valid sequences. Number of valid sequences we have to find out. Valid sequence of k positive integers. Sum has to be n and product has to be even. Since product is even, at least one element should be even. This implies at least one element in the sequence should be even. Right? That's more information. At least one element should be even. At least one element. The sequence should be even. Count the number of elements. N equal to 5 and k is equal to 3. Sequence of length table through sum is 5 of 1 1 3 we have taken on given priority 3 answers. N equal to 3 and k equal to 2. Sequence of length 2 to sum is 2 of 21 41 n equal to 5 k equal to 5. If today 5 then sequence whose sum is 5. Only one with 1 odd product. The answer is 0. K is equal to n, is equal to 5 into the of x. Number of organisms. And you can get from 1. If n is equal to 1, suppose, then that means k has to be 1 itself. That's the question. So if n and k are equal, then uh, suppose n equal to 2 and k equal to 2, then we can write 1 1, right? N equal to 5 k equal to 5 and 1 1 1 1 1 5 times. N equal to 7 k equal to 7. We have to take 7 elements. Some should be n, some should be n, right? The only sequence is 1 7 times. So in any case, there will be no valid sequence if n and k are equal. N equal to 6 and k equal to 6. So I have to take 6 integers to sum up to 6. So that's 6 possibilities, I mean, right? So that's only once. And also to 0 in that case. So if n is equal to k, then you can return a 0 immediately. Otherwise, k is less than or equal to n. K is less than or equal to n. K is equal to n. So finite difference. Product should be even. Will we select k numbers, right? A1, A2, A3 up to AK. So that means sigma I equal to 1 to k, AK into n, right? And A1, AI product I into k is even. Let's give an example. N equal to 5, k equal to 3. N equal to 5, k equal to 3. N equal to 5, k equal to 3. Then have 6 sequences, but only 3 are under even parity production. Some should be at n, right? Some will be n. You have to include at least one even number. Three. So, for example, 1, 2, 1. So then scale of limit to is 16. Number of sequences. Number of sequences which have a sum of n. First, number of sequences which have a sum of n can be built using dynamic programming. N comma sum, db of n comma sum. The state can be db of I comma sum, which denotes the number of sequences till index I of the original array, which have a sum equal to sum. What will be the transition in that? Then equal to length of the sequences k. K can also be 10 power 5, right? Yeah, so we have to include an even number, at least one even number, and that even number should be less than or equal to 1. Just uh, One thing else we can observe, right? We have to observe that sum is n, right? That's what it is given. Sum of all the integers principles is equal to 1. Let's just leave the product condition as of now. We need to find the leave product extra condition and not now. We need to find the number of distinct sequences of positive integers such that of k positive integers such that their sum is n and there are k numbers plus 1. Right? We can write a1 plus a2 plus a3 and so on till ak should be n. And to find the number of distinct sequences of k positive. For example, if we take n is 5 and k is 3. Yes. A1 plus A2 plus A3 is equal to 5. So we can split 5 in how many ways? We can make it 1, 2, 2. We can make it 2, 1, 2, 2, 2, and 1. Other possible ways, and we have to maintain positive. We have to find, we have to find, we have to find number of positive integral solutions of the equation, right? So we have to find the number of quadrant definitions of this equation. And is uh, this is a result in combination discrete mathematics. Which is that result? If we have condition a1 greater than or equal to 1, a1 greater than or equal to 1, so we can add ai greater than or equal to 1 for all I. But we have to make the setting take a2 greater than or equal to 1, a3 is greater than or equal to 1. So we can transform it to something we know ai is greater than or equal to 1. So for I, we can define, or we can uh, define, let's suppose ti, which is ai minus 1 for all I. We can define ti, which is ai minus 1 for all I, and there are much more ways. There are total 6 ways. So let's forget about that. But as of now, can write ti is equal to ai minus 1 for all. And if we substitute, first we know that ei is greater than equal to 0 for all, because ai is greater than equal to 1 for all. We can transform the above equation as t1 t1 plus 1, because a1 is t1 plus 1 plus t2 plus 1 plus t3 plus 1 has to be equal to, or let's suppose we maybe the name is tk plus 1 is equal to n. Then we can write t1 plus t2 plus and so on to tk equal to n minus k. Now we have to find the number of non-negative was given or could give a non-negative number of non-negative integral coefficient of this equation, and we know that we know that what this means, right? We know that what this means. AR equal to N has what was the formula? N plus R minus 1 CR. N plus R minus 1 and minus R plus 1. Live also. We can just check number of non-negative integral solutions of equation. What is the formula? N plus R minus 1 CR or N minus R plus 1 CR? N plus R minus 1 CR. CR minus 1 this. N plus R minus 1 CR minus N plus R minus 1 CR minus 1. Minus 1 here. Where N is this and R is the number of terms. So going by this, we can have immediately the target question is this. This has our number of non-negative integral functions. Different integrals. Possibly non-negatives. Okay. Non-negatives. We have converted this to non-negative, right? AI is a positive only. We don't want to do one, but AI is a non-negative. It will go to 0. Similarly, our mm, target equation with the AI target equation has uh, n. N is this n plus r is k n plus r minus 1 c r minus 1 equal to r minus 2 k minus 1 number of non-negative solutions, non-negative integral solutions. Paste it here, and simplifies to this simplifies to what? This simplifies to c of n minus 1 comma c minus, because these two get cancelled. And minus 1 give us the same number of non-negative integral solutions. So we need to find n minus 1 c k minus 1. We find n minus 1 c k minus 1, we should get 6 for this one. N minus 1, what is that? N minus 1, 4. C2 is 6. And out of this 6, we have to find those which have a product even. How would we find that? How would we find that? In this case, these three are the answers. Yes. In this case, 3 is the answer. Okay, let's check some. Let's see. And if it is 3 equal to 2 is 3 minus 1, 2 is C1, which is 2. And luckily both are even part. And if it is 5 equal to 5, and equal to 5, equal to 5 means 4C4 should be 1. But 1 is the answer, right? But product okay. Okay. Hmm. What about what else? We had basically lecture the product condition of the vintage export. What about the product condition? How can we enforce that? Once we enforce that, the problem would be solved. The product we want that at least one should be given, right? Mm. At least one should be given. we modify this with the condition that all are greater than equal to 0, but at least one should be even. At least one should be even, right? It can be 0 as well. Ti is can be 0, then corresponding AI would be 1. So Ti is equal to AI minus 1. So we have k elements in the sequence. We have k elements in the sequence. So, uh, at least one should be even for the product to be even. At least one should be even. So let's suppose exactly one should be even. Or let's suppose we solve the complement problem. We say that no one should be even. No one should be even. How do I check this n minus k? The number of even numbers from 0 to n minus k. How many are there? Suppose n equal to 7, k equal to 3. Number of, write it below. We have in the equation as well. This equation. Uh, Copy and paste. You can write it. Number of even number from, yeah, in the range 0 to n minus k, both included, is 0 to 2 is 2. There are two even numbers. So every one can take two values if they are to be even. But it can't go beyond. This number cannot take a value between even and 4 because 4 is not even, like the sum should be a minus k, and if this is 4, then it is not allowed. But the thing is that it can go to n minus k, right? Maximum value. Right? That's why we apply the formula number of non-negative integer solutions. N plus r minus n c r minus 1. Okay. So 2 is there, right? Number of even numbers. 2 is there. It can take two values. And suppose no one takes any of the value. No one takes any value. Mm, let's do uh, firstly, water number. mm, There are three numbers, right? Or TIs. We do want it. Okay. So we can write that these k numbers are theirs. K numbers are there. Let's suppose exactly one takes an even value. So that will take from these two. Okay. Even numbers in definition. You want to suppose any one takes an even value. Then there will be two ways. Like, okay, and every other will take the value one way, one way, one way, one way. So this will be two ways. Okay. So that will be two ways. There will be two, uh, what we call this, two value sequences, right? Let's suppose tk minus 1 takes the value uh, even. Again 2 and rest all 1. That will be again 2 ways. And so on we can do this for k elements. 2 ways, into 2 ways, 2 ways, right? And each one of the rest should have only one way, or the one is only for one condition, one condition. Just for exactly one. Or we can just solve the component problem. So this is the big problem. I say that no one should be having a e- even value. All of you guys should have an odd value. Okay, so everyone can have just one odd value, right? There's only one way overall. But some people will not be in that state. Method 6. Probability. Probability of having all ones is equal to minus 2. And case 2, right? All of them won't be even, can't be one. Those sum is 2 itself. Each ti can be from 0 to 2. It's not instructions. But that 6 contains what? That 6 contains 1, 2, 0, 1, 1. 0, 1, and 1. 1, 0, and 1 again, and it says 1, 1, and 0. Okay. They contain 0, 2, 2, 2, 2, 0, 2, and lastly 2 to 0. These are the 6 ways, right? Product should be even. 0 is I want to write like this. What happened? Right. How is it 0 to 2, 0, 1, 1, right? That's will not work. So what would have equals 311 1 E 1 1 1. Right. Let's take some more examples. For n equal to 5k 20 minutes. Total is how much? You can write. You know, 4 and 1, which is 5, you know. You have 4 sections for it. How? One can be 1 and 4. It can be 4 and the right. 2 and 3. It can be 3 and 3. No more possibilities. What will be the again, in this case, all are correct answers, right? All are correct answers. All are going to be even. To solve this. Better.